Okay, we're on section 2.5, effects of changing the dimensions on volume. Let's find the volume of this prism. Remember, the volume formula is the base area times the height. And on this one, since it's a rectangle, the base is the length times the width. So I'm going to actually change the capital B into LW because that is going to be your base area. So on this one, just do the length times the width times the height. So that's going to be 5 times 2 times 4. 10 and 10 times 4 is 40. So 40 cubic feet would be the volume of this prism. Alright, let's look at what's going to happen when we change one or both of the dimensions. Let's go ahead and write in 40 for our original. And then what's going to happen is we're going to change some things. We're going to do a length that's twice as long, a width that's twice as long, and a height that's 3 times as long. Okay, now what's going to happen this time, if the length and width and height they're going to change by twice as long for the length, that's going to make the length 10. The width is going to be twice as long, so that's going to be 4, and the height is going to be 3 times as long, so that's going to be 12. So that's 40 times 12. So the volume of the new prism would be 480 cubic feet. Let's go ahead and finish the chart, this column here. On this one, they want to change the length 3 times as long. There's no change here, so we'll just say times 1 for the width and twice as long for the height. So your length times your width times your height. On this one, your length 3 times more than 5, that's 15. No change on the width, so leave that at 2. And your height is twice as long, so that's going to be 8. So that's going to be 15 times 2, that's 30 times 8. That would be a volume of 240 cubic feet. Let's talk about the next one. The next one, they're going to do, the length is going to change 4 times. We're going to multiply half times the width, and we're going to multiply 3 times the height. So on this one, your new volume, your length, 4 times 5 is 20. Half of your width would be 1. And your height is 3 times bigger, so that would be 12. So that's 20 times 12, so your volume, this one comes out to be also 240 cubic feet. Okay, we're going to notice a pattern here. We've done this before with area, but let's look at this one. The new volume is 480. If we divide that by our original, 480 divided by 4 is going to give you 12. On this one, your new is 240. Your original was 40. And 240 divided by 40 is 6. On the last one that was changed, it's 240 divided by 40. That's going to also be 6. Okay, I want you to notice what's going to happen here. You take these dimensions that change by 2, 2, and 3. If you multiplied this 2 times 2 times 3, notice that it gives you 12. Here, 3 times 1 times 2, notice that gives you 6. And again, 4 times a half times 3, that's going to give you 6. So this is going to help you when you notice the conjecture here would be that the new volume is multiplying the original volume by the product of the factors. Let's write that on the next page where it says what conjecture can you make regarding the effect changing the dimensions on volume. Let's write that out. Okay. The volume, to obtain the new volume, you multiply the original volume by the product of the factors by which you are changing the dimensions. That's kind of what we noticed on the page in the chart we just did. Let's try one. Suppose the volume of a right triangular prism is 360 cubic units. What would be its new volume if one of its dimensions was twice as long, a second dimension was 3 times as long, and a third dimension was half as long? Notice they're giving you the changes here. Let's write down our changes. We have a dimension that's changed twice as long, and one that's changed 3 times as long, and then half as long. Remember, it's the product of these factors by which you're changing. So if you multiplied 6 times a half, that would give you 3. So you take what your new volume would be, what the old volume was, the original volume, times that product of changes. So this gives us our new volume. So that would be 1,080 cubic units. So you really just look at the change in all the dimensions and multiply those to find your factor that's going to make your new volume. Let's look at example 3. Suppose the volume of a cube is 54 times the square root of 3 cubic centimeters. What would its new volume be if one of its dimensions was halved, the second dimension was doubled, and a third dimension did not change? So let's write down the changes again on this one. The new volume, one of its dimensions halved, the second was doubled, and the third was not changed. Now when it doesn't change, remember to use the factor 1 when it doesn't change. So a half times 2 is 1, and 1 times 1 is 1. Now notice this one, anytime you get a 1, that means there's no change, because multiplying by 1 it will remain the same. So your new volume is going to be the same as your original. It's going to be 54 times the square root of 3 times your 1, which just means it's going to stay 54 times the square root of 3. I think I'll also give you the decimal answer. Let's put that in our calculator and see what that would be. This is an exact answer, and our estimate is about 93.5. And this one is cubic centimeters, so we can write it as a centimeter to the power of 3. And that's how you determine the change in volume. When you change something, this is how you just take the product of the factors by which you're changing the dimensions. Okay, now it's time to work some on your own.